So, if I'm not mistaken, people can see that terminal just fine. And move this over a little bit, and people should be able to see that well enough. So, I'm glad somebody pointed us all at Tomacom.com, because after playing around with it, I found that it's actually even cooler than LXR was in some really nifty ways. For example, now normally when I'm up here, and I won't promise that I'm always going to be up here, once again, but when I'm up here, what I'll normally do is try and review what we talked about last week, and then try and go into new stuff. One of the things that I should mention is that one of the reasons why I initially wasn't planning on joining this little study group is because I didn't feel that I could commit to, put in the kind of time commitment that it would take to prepare properly for each session and read enough code to be willing to, or have something to talk about for like 2 hours per week. But I'll do what I can. Now, one of the interesting things, this is why I'm going to show you why I think Tomacom is actually a better place for us to do the studying, is, remember last week Paul said, I would really love to read the kernel command line parser, where it's parsing all those options. And I mentioned to him at the time that, well, the parsing isn't all done in one place. The kernel keeps a copy of its command line, and it keeps it available for the entire session of the kernel, and then various modules and various things, as they become activated, they search the kernel separately. And as I was driving home that night, I thought, okay, if we'd had more time when he asked that question, I should have turned it into the more interesting question, which is, what functions, what kind of helper functions or little internal library functions does the kernel use to find its option and to manage them? So it turns out I did actually find that pretty easily. Let's jump in here. No, that's not what I wanted. Where's the tour?
Oh, by the way, Tamacom's the only one of the Linux source reviewed websites that I found actually works on the BlackBerry. So if you want to try to do it,
if you have a deep, abiding desire to read source code on your BlackBerry, then apparently this site is the one that actually is legible from your BlackBerry. I, on the other hand, don't own a BlackBerry, couldn't type on such a tiny little keyboard, and haven't actually tried that. I also still have an old-fashioned Palm PDA that it does Bluetooth, but it doesn't do any kind of Wi-Fi, it doesn't do any kind of IP, nothing. I'm like a dinosaur. Oh, speaking of dinosaurs, I was at a science fiction convention over the weekend, which is what I do every Thanksgiving, and while I was there, they have art shows at these, and one of the art pieces was a beautifully framed piece, showed two small pictures of crayons, crayon-style colors of dinosaurs, different types of dinosaurs, and they were rendered on punched cards. And the title of this piece was Dinosaurs. It was referring to the substrate of the pictures, not actually the pictures themselves, as far as I can tell. Anyway, so another...
You also said that the letters etched into the code of the cardboard body.
No, I actually looked at what characters were punched out, and they were just random numbers. I said it would have been really cute if they were somehow relevant, but unfortunately.
There's a site that does something on the order of Better Dilbert kinds of comics. I'm not going to remember that. It's a four-letter.com. XKCD. And they've got this one thing where they've got the thing of there's a joke about kids eating the ribbons, the candy that's on ribbons. And it's like some kids would like pick off all the candies and other kids would just rip on it and eat a little paper as well. And some of us would figure out what the horror of the codes were.
Okay, so for the benefit of posterity, Paul is talking about some online cartoon that he read, which Heather asserts is probably XKCD.
Right. Yes.
So Google for that. And he's talking about those old little candies that were little sugar dots that were dropped directly on pieces of paper. And of course, he was talking about 3 different classes of kids: the ones who would carefully pick each little dot off of the paper and eat it separately, those who would just kind of rake their tongue and teeth over the paper, sometimes eating some of the paper, adding a little fiber to their diet, and lastly, the geeks who would sit there figuring out which holorith code patterns they wanted to eat and leave behind, so that they're essentially doing like leaving behind Braille holorith patterns for, actually I imagine some of them actually did real Braille. But on to other topics. So Tomicom.com, in addition to having the Linux kernel sources, also has other kernel sources, which I think is really cool. Like for instance, I thought, how does FreeBSD do its init? And one of the cool things it does is they give you a recommended starting point. So they have this thing here called MI Startup, which I'm guessing is main init startup. So I don't know why they decided to do that in big endian or something like that. But anyway, you could click on that and then read through it, and so you could compare the FreeBSD startup code to the Linux startup code. And I'll bet if we go down here somewhere, if we traced through it, we would find where it's doing its own version of execing the FreeBSD. Well, now FreeBSD doesn't have a sys5 style init process, but it does have init, just like any other Unix kernel. All right, the init tab is totally different than what you're used to, but it actually still has just one process that it starts in that way. And I'll bet if we hunt through this enough, we'd find it. Also notice that one of the things they have is Linux calls theirs printk, but the internal library function in the BSD kernel is called printf.
That's the old nomenclature.
You're right.
Which is a guaranteed way to screw you up sometime when you're trying to cross-platform port stuff.
Perhaps.
Yeah.
You could argue, well, remember, there's no such thing as cross-platform kernel kernel coding.
Actually, FreeBSD does have a shim to honor Linux X.
Yes, it does.
It's a kernel library.
Okay, Heather points out that that FreeBSD and the other BSDs have what she referred to as a shim for running kernel Linux, are you saying a shim for running Linux kernel modules, or?
Kernel shim for honoring the system calls such that userland.
Okay, you're talking about, yeah, tell me if you can remember the name of that one.
No,
It runs user applications, which are designed to make Linux system calls. And
perfect for Linux perfectly in 1998.
yeah, I used to remember the name of that thing. And I just had somebody about a year ago complaining about, asking me about why it almost doesn't work anymore, because apparently the FreeBSDers have been pretty much neglecting it.
They used to call that the compatibility module.
No, they had a funnier name for it. I mean, all of the major versions of Unix under x86 had, at one time or another, added the ability to run Linux binaries. And they had various different names for them. LX Run was one of them. I think that was the Solaris one. There was also one for AIX, and I think they also supported the PowerPC built Linux binaries on the AIX one. In AIX 5L, the L stood for Linux compatibility.
Yeah, but that was in the libraries. In other words, you could compile. You could download Linux source code, type /config, and it would work.
Well, I don't know about the PowerPC AIX one in particular, but the ones I'm thinking of were actually for precompiled binaries. They actually implemented a kernel module which intercepted the system calls that were compatible with Linux. So when you were running in the LX Run style environment, SCO had one of these, as I said, Solaris x86 had one. They all had them, and they all basically intercepted all of the calls that were being made and translated their semantics into the corresponding semantics.
Compatibility was through the libraries and through the header files. For binaries? Not for binaries.
Well, let's not go down a rat hole of which one it was, because I think most of us here would probably consider AIX, the ability to run Linux stuff under AIX to be kind of a niche. So,
The whole
You know.
point of .flash configure is not to need the kind of stuff Jim is talking about.
well, yes, but, okay, the reason why all of these did this is because once upon a time, before Linux became as big as it is, there was this effort called the IBCS, the Intel Binary Compatibility Specification, which was supposed to address the problem of commercial proprietary software vendors wanted to be able to build a product once and ship it on multiple different versions of Unix for the PC. And although Linux at one time implemented IBCS, and most of the others did, this never really gained any traction. But meanwhile, what had happened is Linux had gotten to the point where it was running, there were, 5 times as many Linux boxes on PCs running as there were all other versions of Unix combined. And at that point, all of the Intel-based Unixes basically created little shim things to run, again, proprietary closed source binaries that were pre-compiled. And so in essence, the Linux API, binary API, became the binary compatibility layer for Intel-based Unixes. By the end of, say, well, certainly by the end of the 90s, and then, during this millennium, you hardly ever even hear about that stuff anymore. Although you still hear the FreeBSD people still sometimes are running things like they're running a Linux version of Mozilla so that they can get a hold of the Flash and some of the other stuff that's only released under Linux and Windows, that it's just not available natively on their platform. So that's why I hear about it from time to time. But anyway, as I said, I suspect somewhere if we hunted through the BSD MI start function here, we would find where it starts the init process. I do notice, in fact, this is probably in it, it's somewhere probably right in here. And they also have a panic function. We didn't look at the Linux panic function yet either. Wow.
Sorry, I was just looking at one of the Black Friday's big sellers. It was the N800,
Okay then.
which has Linux.
But it should be the NA10, because that's the old one.
The NA10 doesn't
No,
seem to
number
be
one
out
was
yet.
the N800. But anyway, that's off topic.
Hey, hey,
It's not Linux
kernel. It's not Linux without the Linux kernel.
Hey, at least it's good for
Linux is the kernel.
I think we just, oh, wait a second.
Now you're where you need to be.
There we are. Somehow I was in the wrong place. So this is the cool thing here, when I wanted references, not where it's defined. So under setup is the little thingy that has the kernel search your command line string, and the way it's called is you tell it what string you're looking for and what function to call if you found it. And that's what actually this previous thing, when I click here on definition, one of the things I really like about Tomicom is it actually gives you a little bit of what the contents of those files are over there on the right, so you don't even have to drill down into it to see if it's relevant to what you're talking about. So you see here, it's pound defined under setup string or function. And I looked at both of these to see why they were doing it twice. I don't remember.
That's the same file.
It's the same file, and there's, yeah.
It's
like
a
an
def then.
If death versus, some other.
So let's figure out what the if was. 241, yeah. Here, let me go back up to here. there.
There's an end it right after it.
Yes, I see that. I'm trying to,
There's else.
so that first definition is probably,
And then there's a nested if.
all right, so we have to look for two ifs. You know, I'd really like the percent sign thingy, the percent sign command that you get in VI right about now, although it usually doesn't figure out pound ifs.
Right.
Okay, if,
There they are, both of them.
right,
If end if module,
Line number, please.
96.
yes. These are the couple of ifs. So if it's module, it defines it one way with the name FN, and if it's else, it defines it with FU, what was it, FUNC. So that's some interesting magic to go through. But when we go here by reference, it's more interesting because then what we can do is see all of the places in the kernel where they're using this standard function to search for their parameters. So I personally think that's very cool. And the fact that this one shows you that little snippet of code over there, how it's being called,
That rocks.
yeah, since you don't get that in LXR, this thing here is a great way to look at, oh, how does it set up the APM function? By the way, this is considerably harder to read on this screen than it is up there, but I'll get a horrible crick in my neck if I keep looking up there to cross-reference to my earlier comment about why I'm not going to try it on a BlackBerry. Here's ACPI. Where's
But does your
slash APM?
It'll boot a Linux
There we are.
via a remote Bluetooth connection.
This is running Linux right now, at least the kernel.
Yeah.
All right, so what is it doing here?
One of those like nifty OLPCs or something. Oh,
I do have one of those nifty OL PCs. It's sitting at home right now. I'm really bummed because I forgot to throw it in my Jeep this morning. So, I'm sorry.
Has anybody actually received their order of one yet?
I have any idea. Okay, should I or should I not? Actually, I got in line last, like 2 days before the end of the OLPC thing.
Oh, no, they extended it to December 31st.
oh,
If they extended it, then I'm probably not actually past the end of it. So that's a good sign. If they extended it, that means they're not out.
Has anyone had that using like adding devices like a hard drive?
It's got USB on it, so you can do all sorts of stuff, and it's also got a, what you call slot.
But what about system?
Also, I have been assured by one of the photographs of that project's staff,
So
order it, they're making it.
I'm going to interrupt this fascinating off-topic conversation.
talk about the kernel.
I go hang out.
So it's kind of interesting, this this APM setup. Which I thought I had clicked here. Oh, I see what I did. This thing is just calling it, so you have to click again in order to see the actual function. But before we go there, down below it is something that I also find kind of interesting. Remember on the first day I talked about different types of device drivers? For review, how many different types of device drivers are there?
Block, character, and networking.
Right. And normally you only see 2 of them under your /dev directory. So networking is kind of that dirty little secret. Anyway, this, you can tell without going any further, I hope, what kind of device driver it is.
It's got an I/O control.
Well, yeah, but that's possible for block devices as well. The hint here is that it defines FOPS, which are file operations. That means it's a character device. If it defines BOPS, then it's a block device. That's the fundamental difference between block devices and character devices, is what kinds of operations you have to fill in. You register your device, And when you register it, the structure that you use to register your device with a particular major or minor number in the kernel includes pointers to the functions that have to be called for reading, writing, opening, etc., closing. Yes, Paul?
Oh, you said FOPS, which is like the only place I find it.
File operations.
1855 is,
Mm-hmm.
you know, but yeah, that's.
It says file operation.
Yeah, if I'm just giving you that as a hint. It doesn't actually tell you that here, but if I were to go back, I'm going to actually just open up a new tab here. Come back up here.
Jim, what did you do to get all the references to underscore set up that had that wonderful list right there? What is it?
Okay, so actually I'm going to show, yeah, because I'm going to actually go up one. Yeah, but I'm going to go up anyway. And here you click on reference. And you can also use regexes. So I'm going to search on regex underscore FOPS. It's a regular expression for me because I are very smart.
I'll take that. We be okay with that, all right? No more.
Heather likes to tweak me about my pronunciation of regex. Unfortunately, I have to say, Tomicom is acting a little slow today. Maybe it's the wireless. Is Warren's machine plugged into the hardwire here? No, he isn't. But he's an employee, and it's his laptop, so I think he could do it without irritating our sponsors. Oh, well. Well, this is true. On the other hand, everything I'm doing is visible to everybody here, so, you know, I'm obviously not going to be running Nmap or...
Not to mention video recording.
Yeah.
TCP down.
Okay, well, I'm going to do this a different way because I don't want to have to wait for it. So I'm going to do that, and then I'm going to go home. He has a home button here. Actually, I can even just use back.
What is a Git tour? What does that mean?
Git
Uh,
is the source repository they chose to use. The other one said CVS.
Yes, and in fact, they pointed out that the CVS gateway is apparently no longer maintained for them. So now the only option for the later kernels is Git. If I go back up one,
Tomicom has both of them.
it has both of them, but it says, there's a comment in there.
Yeah, but you can't use CVS for 2.6.24 because it doesn't come in CVS.
Right.
Right. So it says here, this is the latest version by CVS, somewhere here.
Right there. Lower.
No, it's this one. The ones that are lower are Git and FreeBSD. They also have OpenBSD on here if you want to compare to it.
2.6.18. because
Right.
the latest they have is-
So apparently the kernel team shut down the CVS gateway that they used to run for it. I think they've decided if you really want to do kernel stuff, you better learn Git. Or wait for your vendor to package it up for you.
Wasn't there some talk about moving the kernel off of Git?
I think you're one version control system out of date on that. It used to be BitKeeper.
Oh, that's right.
And they moved it off of BK. And what basically happened is that Linus decided he got fed up and he just decided to write something of his own, which was the original Git. And then other people developed it a little further and wrote some tools around it. Cogito. Or I think Heather will correct us and say, no, it's Cogito. I don't know. Just another cog in the wheel.
I don't know, you're the one who went Latin.
No, cogito ergo sum.
No, he wasn't the Japanese emperor during World War II.
No, that was Hito. Sorry, I'll try not to be quite so loud on that. All right. So I was going to look under dot star underscore FOPS, just because I have a suspicion that it'll get us lots of hits, which may define a number of different character devices for us. Now, another thing I'll mention that's,
References or definitions?
Probably references, right?
well, actually, I think I like definitions for this search better.
Hit it.
I already did. Okay, I thought I hit it. So while that's loading, let's go look at that APM setup. So let's see. Oh, that's kind of cool. Now this one, notice, is the combined 386. In the Git repository, we're looking at 2.6.24, and that's where they've merged i386 with x86-64. So that's why we're seeing that one. And this other one here is kind of interesting. They apparently have some kind of APM emulation as a character device driver. So maybe it's something that stubs out the APM functionality on a machine that doesn't support it.
Or something like that.
Don't know. If we click on it, maybe it'll have some comments in it for us to read.
So ATM is what, below the battery?
Advanced power management.
As opposed to completely scattered to the wind power, basically, yeah.
Yeah, that's what I was trying. That's what I was trying to figure out.
Okay, well, there wasn't much information in that. I'll have to look at it more some other time. Wait a second. Oh, that's the setup. I thought I already followed this link once. I guess that other one is. No, that's another setup one. Okay, well, let's follow the link anyway. Come here. All right, I feel like I'm going around in circles here.
Those are references. Do you want the definition?
Yes. Oh, I see what you're saying. Good catch.
I've never seen this before. It's cool. I would wonder, is the source code available for it?
In fact, they do make the tool available, and there are bold letter thingies around here saying, if you're interested in this stuff, please do not try and download our entire HTML tree of 500,000 Linux files. Please just grab the source code or the tool, build it, and run it against your own copy of the source code.
Yeah, that could take a while.
So this tool is GNU?
Yeah, I believe it's GNU based.
What's it called?
Global,
Global, yeah, that.
global source code tag system.
There you go. Yeah, that. I believe it may have actually started way long time ago.
Oh, yeah.
Something called id, which was something we could run on source code that would do a whole identifier database thing for it.
Yeah, here's the link that we're talking about.
Can you just-
Hello.
Overheat,
I don't know.
where's Warren?
I think they're busy getting their trouble.
Oh.
Any ideas, guy?
Well, the other maybe.
Analog.
How good is your shadow puppetry?
We need a light backlight for that, and that's
You can do it. It's
over.
got a little shadow there.
We probably just have to wait until it cools down, because it's just overheated.
Well, I guess we're taking about a 5-minute break.
Yeah, that's a great idea. Anybody that needs to use the facilities to sort of working on it, right?
Oh, system wait, shutdown in progress.
Oh, it might be like a timing thing that they shouldn't have. So we can bring it back to that.
Computer shut down, probably is a little rough.
Okay.
We'll have to wait to shut down before we get back up.
Shut down before the projector cut out, so.
Right before it bought it, it said something about two signals, so I'm guessing maybe is it plugged in? Is it a power? Hi Warren, we're screwed again.
What might have happened,
What happened?
it just decided to shut itself down like it had no signal or something, which is funny because you're still fine here.
I did have an idea, so,
Here, let me see.
adding trivial functionality to the Linux kernel for community benefit.
The hell?
Jim?
Yeah, I've done a million of issues. I've never experienced anything going off.
So it just went off.
I'm bring it back up. I don't know if it was like it's on a
Maybe he
timer or
touched
something.
it or something. Yeah, that could be. Did they just stop like right before we got back, or?
Yeah, they just
Okay.
turned off for some reason. I thought
There
it was
it's
because
going right now.
I thought it was because he wasn't doing anything on here. 'Cause
Yeah.
usually it'll just blank out and just retouch it, right? But he was
Put them
working
in
on it.
presentation mode so that it doesn't do that. So there we go. Now it shouldn't shut off.
I don't know.
These things just went off for whatever reason. They're not getting a signal, are they?
Well, no, I didn't get from British Telecom, it's somebody, who had British Telecom.
Was there any stress on this thing? I mean, this cable looks like it's been bent, but I wasn't messing with it at all.
I don't think that's what it is.
They overheated.
Well, this
Hey, Rachel.
the only Motorola uniform. It has ULA. Unless it's mobile access.
See what we got here.
Hotspot, mobile hotspot at home thing.
So we just take a little break.
Yeah. I mean,
Okay. I'm just gonna log out and log back in.
It's actually the same chipset, the Marvell 8388. No, actually, this isn't the 8388, because that, the one the OLPC has is the USB flavor of the chipset. This is the SVIO thing.
Has anyone been able to add RAM, system RAM to the OLPC? Or is it
Not to
limited,
my knowledge,
is it limited to the chipset that's just
as far as I know.
I really suspect that if you want to add RAM to an OLPC, you're better off actually just buying a different PC.
That's probably a good idea.
The OLPC has a lot of nice properties. It's,
Like the display.
Is it set for the?
it has wireless, it's ruggedized, children
There it goes.
Oh, yeah.
Something. Yeah. I have no idea what was causing it. Hey Jim, can you log back in?
Okay. Wait a second, you had to reboot?
No, I had to get out of X and back in. I'm not sure what was actually causing it because I also unplugged and replugged. So
Uses open firmware.
Well, it couldn't be a DPMS thing because the screen blanker never kicked in.
no, it's either a bug in the driver or this thing actually was losing signal. I'm not sure which. So I don't seem to be able to recreate it. So I have no idea what the issue was. Anyway.
Nobody was complaining about any flickering or anything, and I was looking over my shoulder a lot.
No, I doubt that it was flickering. If I had to blame it on something, I'd blame it on driver. But anyway, it should be okay now. So when you log back in, I don't know, it may try to reopen the applications you were using, but they probably won't come back to where you were. So
Oh, you have root at Google.
Mozilla or Firefox should
Machine's
try and
still
open my...
shut down, right?
my machine didn't shut down. And the machine, I'm not sure what happened, but it didn't. But it was actually still in X. So I don't know.
Everything
Anyway.
was fine on this end. It just stopped there. But his remediation involved kicking me out.
Or they try everything at once. Something's got to work, and now we can get it fixed faster that way.
Restore session is my friend.
Yeah, I think we're all good.
Yeah, it is.
Let me just say that I'm really glad they added that feature. If you're gonna have a buggy piece of software that keeps crashing on you,
It's important to be able to restore.
Anybody here read Val Henson's article on crash-only computing?
Yes. I thought that was a great article.
What's this?
It was the fact that you're supposed to design a program. He actually found, sorry.
Valerie Henson.
I didn't remember who it was, and that's, anyway. I think that it's the same article that I'm thinking of, though, but this person, basically, she said that, that software, when you crash it, will come back faster. Like, if you take a Linux box and pull the plug on it and then reboot it, it boots up faster after a crash than it would after not having done that.
Not exactly what she said, but
Well, in a lot of cases, that's a big part of what she said. But anyway, but if
she said the software that is properly designed to crash will have this property.
right, well, she was using doing that to operating systems as an example of how they actually rebooted faster, but that everything should be able to essentially stop with no notice. And, you should be able to basically pull the plug on your computer to shut it down. And
You can do that on AIX usually.
it depends on the program that you're using.
It's designed not to crash, then when it crashes, bad things happen.
That's right.
If it's designed to crash, then crashing it doesn't do anything bad.
That's right.
To an AIX server, by the way, you're pulling the power from it. That doesn't mean the server's shutting down. That means it's got some internal juice, and it's running its final, like, disk syncs and everything else while it's unplugged to actually do all the right syncs on the way out. And that's only with
Anyway, are you
specific
ready here?
hardware.
I had
Yeah.
to find
Cool.
a workstation when I find out that it doesn't.
I'll watch it. If it does that again, I'll.
But the thing is, it only syncs the actual data. It does the metadata, but not the actual data.
Okay.
So I have a suggestion.
As far as I can tell, it has no battery in it. It's been unplugged for a month. I'm not sure when it's gonna run out. I'm figuring out what time it is.
I have a suggestion. Let's save that for afterwards.
Go back to the kernel.
All right.
But that's a time.
Yeah, the new global, that's, it's another one of those awesome open source solutions. I think, I'd love to see SVLUG actually start working with its own copy instead of actually going off to Chemical and all that, so I'll see what I can do about getting.
But why? Why would you do that? The good thing about open source is you distribute the load. Somebody says something, another person says something. We don't have a really, the setup that we use is a really good idea, but we don't really have a really good,
I mean, if it doesn't.
This is why
install or
Telecom
work,
is here.
I mean, there's nothing wrong with installing it, trying it.
Well, you can try it, but this is here.
This is a search application. It should be hosted at a large
sometimes
search
graceful
infrastructure.
failure.
Oh, that's an even better idea than SVLUG do it. Oh, well done. You walked through the big open door I left them. Hey, Warren, what do you, why isn't Google actually handling hosting this awesome open source app from GNU that'll let everybody on the planet be able to go look at the Linux code?
Isn't that what Google code that Google.com is?
No, actually, that's a different answer. That's more like,
So I'm not trying to put you on the spot, dude. I'm not.
that's more like a repository of cool code type answers.
Oh, I see. Well,
I'm going to try and experiment and see if I can sit in something approximating a comfortable position here.
Unlikely.
You said it was not.
You want a different chair? And a table and whatever.
I'll just do what I can. Okay.
This code is buggy. This pointer is null right here. Buy Covert.
Wait a second.
You can sell code coverage right next to the back.
There you go, man. Check it out.
Oh, man.
So it occurs to me that maybe we are not able to find that APM setup function in here because
623.
Yeah, 623, right above the little.
623, okay.
APN setup, isn't that define that function right there? Yeah.
Right. So what is it setting up here?
It's checking to see whether the argument says off or on or something else.
And then it's setting a global variable named APM disabled.
By star stir, it's actually looking for nulls inside of the thing.
Looking for a comma.
So it loops around, right?
Yeah, the stir is looking for a comma.
And it's not stir.
Stir code.
Yeah, stir-cur. I think there is also a stir function defined in the kernel sources,
Yeah, but
as well as a stir-cur, yes.
Right there.
So that,
What's stir span do, Jim? Below that, one over it, to the right?
SPN.
What's that?
That one, I believe, emulates the same function in C.
so this is a version of the kernel one that replaced a lot of, the string compare with numerically bounded string compares.
Actually, they've done that for a long time.
In your
So.
kernel source, there is a folder called lib.
Yep. We can see all of those there. And in fact, I was actually going to point to that. So, good segue. Come on, I can find it. There it is. So, one of the things, let's see, ST, it's around here somewhere, all the string functions. One of the things that sort of galvanized the kernel source community to put together a library directory and a bunch of standard libraries is when somebody went through and found several different, I think it was 5 or 6 different implementations of MD5 checksumming in different places in the kernel. Multiple instances of zlib, multiple instances of different CRC32 and MD5 checksum and other, or MD5 hashing. So.
Keys is a little bit different every time, won't that help security?
No.
I think not.
There's probably people out there who are going, ooh, that was a great idea. That sounds really scary. This Bruce guy, he's got a
Even today, as code is added to the kernel, they end up duplicating stuff that's already there, which eventually gets recombined and moved into lib.
Hopefully. Eventually.
Ideally.
Okay, so that's enough on that particular one. As I said, I think that this ability to check all these underscore setup thingies and go through here could be really useful when you're trying to teach yourself what, basically where the setup is for a lot of these functions. But we might find out, as I've been looking at the APM underscore setup, I'm kind of wondering what happens when these things are modules. There's going to be a stub in the kernel that's going to handle some of the functionality. And then when you actually attempt to access any of the actual functions, then remember what's going to happen. So if you define it as a module, there's going to be defined entries there for the operations, but when you attempt to access them, they're all going to be linked into a part of Kmod, which is going to try and satisfy those dependencies for you by loading whatever module actually supplies the functionality we're talking about. So another thing I want to do is I was looking for the function in the kernel that handles the timer interrupt. And the reason for that is that directly or indirectly, almost everything else that the kernel does is based on the timer, the main system time. So remember what I suggested the first day that we were here for what you should do when you're looking for a piece of kernel functionality? Anybody want to yell it out?
Ask Jim.
No, that wasn't it.
Search Google.
Not quite.
Go look at the earlier kernel.
Oh.
Minus R.
Go look at the earlier kernel.
Well, I suggested looking at earlier kernels or comparing it to other kernels as a different step, but that's after you look something up. Although I did suggest that when you know what you're looking for, trying to find the earliest kernel that probably had that might be a good thing. On the other hand, this particular site, one disadvantage of Tomacom is that it's only showing you a couple of versions of the recent kernels. If you want to go back to 1.09, then you're either going to have to go back to LXR, or maybe, if you wanted to do something very handy, Paul, is you could grab the global tool here, global tagging tool, grab a 1.09 and a 2.0 something and a 2.2 and a 2.4 and rerun it on all of those. Focus on the older ones, and if you do that, actually, if you do that and you talk to these guys, then they might link to your, for older versions of the kernel, go to these guys. These backwards posts. Oh, did I say that with my outside voice?
You already do that for LXR.
Digital Luddites, that's what we are.
Nothing good was invented after email.
So this web thing, it's just a passing fad. Oh, sorry, for the recording, Bruce was saying nothing good was invented after email. So now you guys watching the video get the punchline before you get the joke.
What about chat?
NTP?
You're supposed to have bad memes.
No, chat was invented after email because you didn't have consoles of the same machines yet.
No, chat was invented before email.
So,
Wall, one terminal to the other.
right. So what I had suggested is, before you go look at a piece of functionality in the kernel, ask yourself what you expect to find when you get there. So what are the things that have to be done by the kernel during its timer interrupt?
Check the IRQs.
Well, somebody asks if there's a watchdog. So my question about watchdog would be, would that be handled by the kernel or not? So a hardware watchdog driver would be a hardware device that you poke a value somewhere into it to set off a time at which it will strobe the reset. And so what the kernel will do for a hardware watchdog driver, and having written one, I actually know this part, one of the few things I actually had experience with, funny you should bring it up, I'll have to pay you later, is for a hardware watchdog driver, what the kernel will do is it's a character type device, and the kernel will relay things from user space out to the actual device. And that's all it's going to do. So it's not actually going to pet the watchdog itself. But there is a kernel soft dog or software watchdog driver, which basically the kernel will maintain as an emulated watchdog device, so that if you don't pet the dog, periodically, then when it reaches its timeout, the kernel will panic. So it's slightly different, but it's the same concept. So yes, if you have the soft watchdog enabled, then the timer interrupt presumably has to go and check and see if you have done that recently. Although, let me think about this for a second.
There's still circuitry involved.
Yeah, it still has to. It has to do the count. Well, no, the soft dog will work on anything that has a timer interrupt, and you can't run a kernel without some kind of timer.
Registers that are always auto-incrementing, and so there's hardware associated with that, and it sets off a kind of interrupt that the kernel responds to if it reaches the wrap over.
Okay, a hardware watchdog has its own little timer in it. Yes, and if you initialize it, then you initialize it with a value, and if the count ever reaches 0, then it strobes the reset line in hardware. So if the kernel itself hangs and doesn't do anything, the machine will still reset if it has a hardware watchdog. If you don't have a hardware watchdog, or if you're not using it, like basically, as far as I know, all of the modern motherboards, they actually have a watchdog feature in the chipset, in the south bridge, that strobes the NMI, the non-maskable interrupt, if it goes to 0. But not every motherboard manufacturer wires that chip, those lines of the chipset up that you can actually access them. That's one problem. And the number 2 problem is that the various different chipsets that we're talking about often don't document how to get at it. So you might not find the hardware watchdog available on your system, or you might not be using it anyway. You might be using the soft one. A software one is just a kernel driver.
It uses the program counter. When the program counter wraps,
No, it doesn't. We can go read the source code if you like.
okay, let's
As far as I know, what it does, it maintains its own driver, its own counter, and whenever your user space,
where that counter is.
well, let's look it up.
It's actually
Let's look it up.
Yeah, let's look it up, please.
Did it move? Maybe
Now, this will probably have several hits.
it used to be right and the other one's right now.
So what I'm going to look for, and somebody can help find it on the screen faster than I can read this thing, probably. I'm looking for the software watchdog driver.
More. We can't.
Feel free to like scribble.
that's its own kind of blue screen of death. Blue screen of battery problems. You know, I've been using this lately at home, and every time I use Microsoft,
This doesn't,
it's so bad.
Warren? No, Warren? Warren, your thing does not have little places for the screws to go.
I tried to screw it in, but it didn't work.
I see. So maybe we just need duct tape.
All right, we've determined that that won't work.
You know, we have some suggestions.
Thomas Alva Edison, upper Earth, tried over 10,000 different ways that would not make a practical light bulb.
Hit page down while you're messing with that.
Yes, please.
Yes. And people are always welcome to follow along on their own screens.
But you do it so much quicker.
Does your screen have a tendency to go blank if in the signal?
Wait a minute.
Archie's, go back up to
Kernel time, stop.
So you think it's this one. What I'm actually going to do is search on soft watchdog, but I'm going to do it in another tab.
Something came up and I just thought, watch something.
But it's interesting that so many I/O drivers actually have watchdog timers built into them.
There are actually several soft watchdogs in there. There's a whole folder.
Aha. Well, the folder should be for the various different hardware watchdog drivers, and one of those entries should be maybe under drivers, characters, or car, or watchdog. So these are for various different motherboards, chipsets, and external, like PCI. And then one of them should be softdog.
Third from the bottom, second call from the right.
Thank you.
You know, this is nicely organized. They cleaned up a lot of stuff.
Yeah, Alan Cox did a lot of the watchdog stuff himself. Which is why I mentioned that the one time I wrote a watchdog driver, I took one of his, ripped out everything that didn't apply to my hardware, which is pretty much everything, and poked in the 3 or 4 values that did.
So it has various calls. It can send a message to a NID, or it can reboot.
Good coders borrow, great coders steal.
What's the value that wraps?
No, if you steal from more than 3 sources, it's called research.
I'm thinking it might be the timer margin. Define timer margin, soft margin equals timer margin.
Yeah.
He has a little if-def there just so that he can see when it tests, just for his own testing purposes. Presumably so he can do things like run this thing, let it time out, and listen to it fire without actually rebooting his machine in the process. By the way, when using Watchdog drivers, I highly recommend testing them on a bench or being within arm's reach of the machine before testing them. It was the one time that I was working as a sysadmin for some company, and I decided to deploy hardware Watchdog timer configuration to a bunch of machines that was in a colo 30 miles away. And it got confused. It ended up using the wrong one and going into a reboot loop. At least it was only 30 miles away, and I was actually able, with a little persistence, to get in and kill the Watchdog initialization in an SSH script during the time between it when it booted up and when it rebooted itself. It was ugly. Yeah, less than 1 minute, because basically I had my little script busy looping on trying to connect to it and run the command that would shut down the Watchdog driver without rebooting the machine. And got lucky.
Shut down Watchdog, shut down Watchdog, open up Watchdog, open up Watchdog.
So tell me about why you want a soft Watchdog timer. That's an interesting problem.
Well, okay, so let's consider the situation here. What the Watchdog, remember, a Watchdog driver in the kernel side is only responsible for rebooting the machine if the Watchdog has not been petted after a timeout. So in order to use that, you have to have...
We mean reset to its initial value, or set to a value so that
0 or something.
Okay, Watchdog 101, you plug a value into the register, that enables it. It now counts down from that value, usually in seconds, and if it ever reaches 0, it reboots the machine. So petting the Watchdog means pushing a new value into that to keep it running, never letting it hit 0.
Okay, all I'm pointing out is that on some processors, the value is not 0. Because some Watchdogs count.
Okay, when it reaches some magic value, whether it's full house or 0, normally you expect that if it's full house, all ones, FF or whatever, that situation means the Watchdog is not even enabled. It's not counting at all. So it'll never reboot. And when you push any non-full house value into those, but in some of them, like the one that I did, you pushed a value into one register and then you pushed another value into a different I/O port, and that started the countdown.
Yes.
And then you continually pushed values into the register to make sure that it never hit its target value. Right? Whether it's an overflow, as far as I know, most of them count to 0, but whatever. Let's not get lost in the details. We can read the source code for its details. You ask, why would you want a soft one?
Yes.
The reason is because then using the same user space software that you use to check the health of the system and pet the Watchdog, you can do it whether or not your hardware supports the Watchdog. So that as long as the kernel is still alive, then even if all of user space goes south, the kernel will eventually time out and reboot the machine.
Oh, so it's like adding a feature to defectively designed hardware.
Yes, it's like letting the kernel work with defective hardware that does not have a feature that most hardware should. In a lot of PCs, especially the old ISA-based PCs, there was no Watchdog timer built into the chipsets, and you bought a separate small ISA card. That was about $100 or so. Black Box used to sell them. I think they still do.
These software implementations, these subsystems are also helpful for people when they're verifying that the subsystem works, that they don't want to have to make the hardware work also. It makes it
Yeah, Warren's also pointing out, just for the benefit of the video, that also if you're a kernel maintainer, you might want to use a soft dog and use that little if-def thingy so that you can test the functionality without actually rebooting your machine and without having to do special hardware.
That, and also test the functionality of the entire subsystem, because you may not have the, you might be able to introspect further into it when you have software, you know, playing the device rather than an actual device that will reboot the computer.
Yes. So I'll also mention that it's up to the sysadmin who's enabling watchdogs to actually put some suitable software into place in user space that initializes the watchdog and then periodically pets it to make sure the machine doesn't reboot. And it's kind of silly for it to just do nothing but sleep some amount of time, like 10 seconds, pet the watchdog, sleep, pet the watchdog. You're not actually testing any other functionality. So if you look at the Debian package named Watchdog, which is a user space utility for doing this, it actually defines about a dozen different tests that it does. And it has a couple of hooks in it for doing user-defined tests and remediation. So what it does is it forks a child process, makes sure that that succeeds, so your process table isn't full. Then it sends a signal, make sure that it received the signal. So it's testing that signal dispatching is working, and the system isn't thrashing so badly that the dispatch signal never manages to get back to it in a timely fashion. And it can check, most of these, almost all of them are optional. So as I recall, it tries to open a file, like its own PID file, and read it, something like that. Make sure that the file system table isn't full. And you know, you can read the sources to it, and it has another feature where it will, if you define a particular binary or shell script, it will run that, and as long as that exits with a 0 status, then it considers that to be successful, it's okay. If it ever exits with a non-zero value, then it says, we have a problem. And then, if you define a repair script, it will call the repair script with a code telling it which test failed, and you can attempt to repair things, and if you do successfully, then you exit 0, assuming you're using like a shell script, but you can also use C code or anything you want, any executable. And if you exit with any non-zero value, then it will continue to do the shutdown. The other thing about the Debian Watchdog one is, in the event of timer failure, it will attempt, or you know, other failures, it will attempt to actually do its own shutdown of the machine. It will stop petting the watchdog, but it will also attempt to do a clean shutdown. And the way it does that, they actually include all of the code from the shutdown command directly in it. So it doesn't try and do an exec of the external normal shutdown reboot commands, because that might be failing already. It actually has that code redundantly linked into it. And normally it schedules itself with real time. It runs as root with real time, so that it's locked in memory and it gets scheduling advantages. So, you know, the whole process of using watchdogs actually is not trivial. You have to think about, what does a healthy system look like? What does it mean to be healthy? Another thing that a lot of these watchdog timer software will do, and a lot of the watchdog cards will also do, is they'll have temperature sensors in them. So if the machine is overheating, they will also shut down the machine.
Okay, so watchdog has actually become a term that's been made more generic, and it encompasses more than just hardware timeout on IO transactions.
So John is saying he's interpreting what I'm saying as that watchdog timer, the meaning of it has extended beyond its own. I would say no, I'm just babbling about things that are related to it and are often implemented on the same add-in hardware, and to some degree might be included in the same user space drivers. Remember, the user space drivers function is to say, if the system is healthy, pet the watchdog. So defining what does healthy mean.
Originally, it was just if the kernel was moving in some way that it was basically locked up. Originally, it was very narrow.
Well, okay, so
There's also another.
perhaps. I mean, you could design a kernel, and perhaps some other versions of Unix actually have a thread in the kernel petting the watchdog. You could do that in Linux, and that would mean, okay, my kernel is fine, it's running. So even if all of user space is completely hosed and south and there's no response at all, then, oh well, at least the kernel's still running. Now, how useful is that? That's up to you.
I've been there before, though.
On an industrial controller, what we would do is we would actually have several bits in the watchdog that all had to be independently tickled so that the machine, there's the case that you didn't want your machine getting into a tight loop where it was tickling the watchdog for some reason and not controlling the thing and burning the factory down. So it had to go and...
So if I'm understanding Larry correctly, he's saying that on some of the kinds of hardware that he deals with, which is a lot of embedded systems, that they have, instead of a simple countdown, one global value that's being counted down, they have like a bit mask, and various different components of the system are responsible for periodically triggering their bit. And on that system, it's going to mask the bits to see that they've all been set in some reasonable amount of time. And if they haven't, if any of them are unset, then presumably when it masks these, it's going to clear the bits and then check and see if any of them were unset.
Well, basically what you do is you have the thing that reads that as one of them, and when they're all read, then you go and reset the watchdog timer. But the important thing is that you require several different portions of code to pet the watchdog, otherwise it...
So it actually sounds like the register that you're talking about that has several different bits is not the actual watchdog register, but rather is a register used by what I would think of as the user space daemon. Hit that. The user space daemon is checking to make sure all the bits are set, and anybody who doesn't set their bit, then the whole system is declared to be not functioning properly, and it will rebit the whole thing. And you could emulate something like that in the user space portion of the watchdog by, for example, having it start up a number of subprocesses or listening on a set of, for instance, Unix domain sockets, and then doing a select loop and keeping track of there better be some kind of input on every one of these sockets during every timeout, or I'm going to declare the system unhealthy. And you could have a whole collection, however many you wanted to create, of different entities voting on the system health. On the other hand, normally, if you look at the one that's for Debian, your better bet is probably just to use it and use its extension. The point is that in this case, the Linux kernel only provides the mechanism. It doesn't set the policy. It's providing a mechanism for something out in user space to do that, and I was giving an example of the most commonly used one, which is maintained by the Debian people. And I mean, I personally have repackaged it using Alien several times to go to different versions of, for instance, Red Hat.
The mechanism can also be in user space if the watchdog kind of, not really a watchdog, but it kind of does the reverse. For example, say you have a reset switch that doesn't do anything to the hardware except flip a GPIO bit. And then it's up to a user space daemon to pull the kernel's broadcast of what its GPIO lines are to see when the bit is set, and when the user space daemon polling determines that the bit has been flipped, then that indicates that the system is unhealthy, and it sends a signal back to the kernel.
Okay, I would not call such a thing a watchdog, because if the user space thing fails, it just fails open. So, I mean, the fundamental thing that makes it a watchdog is that it functions like a dead man switch, okay? If the switch is released, if it fails, if anything in the chain fails, then something way down lower is just going to reset the whole machine. Whereas that thingy that you described sounds more like, basically like a one-button mouse with no wheel in it. And a user space program like connected to GPM that just triggers something, like kill switch. Yes, and that's why on most of our laptops today, when we actually need to power it down, we have to hold the power key down for 4 seconds. Because we have to get past the, oh, I'm just going to notify this piece of software that you should reboot now. Yeah.
Right.
Yes.
And this is not technically a watchdog, but the term watchdog is being extended to that as well.
Okay, I'm not going to, anybody who tells me that they're going to call that a watchdog, I'm going to say, that's nice.
Watch puppies. There you go.
So,
Every kernel needs a block.
I did assert earlier that every type of Unix kernel requires some kind of timer interrupt or some kind of timer events happening.
2 minutes after 9 o'clock, do we have time to briefly describe the tickless patch and the tickless kernel?
I suppose, although in that particular case, oh, okay, so it's Graham, right? Greg. You know, I hate it when I forget your name. Anyway, Greg asks about the tickless kernel, and I read about that, I think, probably on LWN a while back. And if I recall correctly, the tickless kernel patches was an effort that relates to the virtualization, the ability of Linux to run as a guest under itself is one of the usage models.
It's not just that, it also has to do with power saving. So instead of having it wake up every so often when there's nothing to do, so it can know when there's nothing to do for the next, however many milliseconds. And instead of waking up
Right.
at every time slice, it will skip to the next, time that it should be awake. It will wake up then. It will
Right.
make adjustments to its time, to the time slicing stuff so that you
Yeah.
know where it is, and then it will wake up. That way it doesn't have to wake up every time slice.
So,
So that it does not function as its own keep alive timer.
right. So the gist of it, though, is that in that situation, you haven't actually done away with the timer. You've just gone away from the assumption that the timer is going to be a simple, regular period. That it's going to, well, not even just synchronous.
It's on scale, it's probably a couple of orders of magnitude different from the cycle rate.
It's synchrony with a hardware clock. Once you break the synchronous.
Right. So in the case, in the case where you can say, okay, everything in the world is quiescent, I don't actually have any work to do until some hardware event occurs other than the normal timer interrupt, the normal hardware timer interrupt, then you could go to sleep, because I did say that most of the kernel functionality is hooked into the timer, but remember, there are also these other interrupts. So any I/O comes in on any device, I got to wake up to handle it. The bottom half is going to do whatever it needs to queue up that data and schedule the top half, and that's going to wake up the ticks again. So in essence, all of your bottom half handlers are going to be stubbed through something that wakes up the ticks. And what will shut down the ticks once again will be the kernel after it's done all of the scheduled work and it sees there's nothing else to do. Yes?
On the one laptop per child, as I recall, it's part of the design that it puts up a screen full of text, and then the processor can actually halt as a power saving thing until it hits the key to go to the next page. So nothing happens at all. It's the opposite of the DRM thing.
Have they actually made it there yet, bro?
Well, I don't know. but
It's
I'm
not
very
exclusive to the OLPC. That entire architecture, the Geode LX and the other Geode CPUs, have that as one of their basic features. It's one of the reasons why it was chosen for the OLPC.
Oh, and the other keyword for it is DIN tick, dynamic ticks. I remember that now. So anyway, let me think here. I would still assert that most of the operations of the kernel depend directly or indirectly on the timer tick, except obviously for interrupt handling. And so the situation you're talking about is where the kernel, in essence, shuts down for periods of time. We haven't actually talked about kernel shutdown, but it's one of the things that I put up on the wiki page at the beginning is, we talked about where the kernel starts, and it's natural to ask ourselves, well, how does it all end, right? And as far as I know, the end of a kernel session only happens possibly 4 different ways. You kick the plug, you run the shutdown function internal to it, which obviously is called by a user space program normally. By the way, kick the plug also counts as when a watchdog timer kicks the plug for you, would count under that category. Shutdown, panic, and there's a funny little thing that's kind of unique to Linux, and Warren and I were talking about it after the first session that I was at here. And it's this weird thing called kexec, right? Which is why I put it on there.
Weird new thing.
Well, new is a matter of opinion, and well, but there were versions of patches that existed. The 3 kernel Monty, or excuse me, it was actually called 2 kernel Monty, a reference to 3 card Monty, was similar in concept. The idea that we could patch the kernel so that instead of doing a normal shutdown, we convince the kernel to load a new kernel image and boot it. Right, that was the Monty one, and what Warren was telling me is that the effort in kexec is to actually go even further and not only load the new kernel, but start it running without killing any of the user space processes, basically passing all of the necessary information over to the new kernel so that it instantiates its own processes with the same process IDs into that new kernel, which that's quite a challenge, but it would allow you to do a kernel upgrade without rebooting your machine. And that combined with pivot root could allow you to do a rather complete system migration to an entire different distribution or a different version of the operating system without actually rebooting, because you could load up your new file system in a chroot jail, install everything into it, and then pivot root onto that, and then the old root file system would be gone. Now, I know we didn't talk about pivot root. Now, last week I remember we talked about the old initial RAM disk and init RAM FS, and how that is mounted temporarily, created by the kernel, mounted temporarily as the root file system, and a process is run inside it. The old initial RAM disk model, it actually looked for an executable named LinuxRC. In the new one, it actually looks for a process named init, which if you go into things like the Red Hat, or I think most of the distributions, you'll find a symlink from LinuxRC to init in your initial RAM FS. So what we didn't talk about was what happens at the end of that process. So in your initial RAM disk, in your LinuxRC, you have done one of 2 things. You've either loaded some modules and done some other stuff, and you're happy with that, and you just let it drop off the end. In that case, the kernel is going to attempt to load, as in mount, the root file system just as if there had been no initRD at all. It's going to look for a particular device. Probably your LinuxRC loaded a device driver, some perhaps weird proprietary, hardware RAID controller driver, or some iSCSI modules that, with information about what storage device to use remotely. Who knows what. But then the Linux kernel, when it starts, it will attempt to mount its own root file system and go through the normal boot process. That's one possibility. The other possibility is that your LinuxRC actually mounted your root file system for you. If that's the case, then you poke a special value into /proc sys real root device, real root dash dev, I believe it is. You can read all this in the initrd.txt file under documentation, by the way. So you've done that, and then you run a pivot root command or function, and that's actually because, like for instance, in Nash, which is the not a shell provided by Red Hat, What most of their initial RAM disks are, the Linux RC is just a small script using the Nash interpreter. Whereas on Debian, they actually ship a copy of Ash, which is a simple shell.
Dash now?
It might internally be Dash. The last one I saw and ripped apart was a copy of Ash, but you know, Dash and Ash, the Debian version of Ash are, I'd be hard put to distinguish between them. Yes. No,
Dash is not used for that.
no, you could put, I have made, yes, no, there's Nash, there's Dash. One I have used is BusyBox. If, depending on how you compile it, it also has a shell built into it. No.
It's a full batch.
Actually, the one in BusyBox is, I think, a modified Ash, but it does have tab completion. I don't think it's actually a full bash because it's a lot smaller than bash. But
It has a lot of bash stuff, not just the tab completion.
yes. So the point I'm making is that near the beginning, you have this whole pivot root concept, which is a system call, and there are various little standalone utilities or commands built into the different shells that are used in initial RAM disks that are just wrappers around the system call. And so pivot root takes two arguments, where your new root is and where to mount. It doesn't actually unmount the current root, as the name implies. It actually mounts you mount the new device, and you point at its mount point, do pivot root, and it twists that around so that that's now the root, and whatever used to be the root is now normally on its /initRD subdirectory. But that's actually an argument to pivot root. If you like, we can actually look up pivot root here.
And then you're free to unmount that.
Yes, at which point you can unmount it. And in older versions of the kernel,
Only after you've all the programs that have executed in your initRD have released.
Yes.
if you attempt to unmount it, you'll get the same error message as if you attempted to unmount anything else where the file system was busy. You'll get file system is busy.
Open file descriptors are still open file descriptors, right?
Yes, and that's the whole,
I'm
yeah.
just making that point because you have to specifically design your scripts to stop.
Yeah. Also, if you ever are playing with like the Red Hat, these days, newer versions of Red Hat basically cannot function without an initial RAM disk. I mean, you have to, it used to be, like in RHEL 3, you wanted to do away with your initial RAM disk, no problem, bing bang, it's gone. And in RHEL 4, it seems like you could get away with it pretty much by just, as long as you weren't using LVM on your root file system, you could get away with just changing FS tab, changing your grub, so that the root device was given by device name, not label, and then you could blow away your initRD and you'd be fine. In RHEL 5, it seems like it's gotten, last time I tried it, it was worse than that. It has some weird stuff that you really need to run in initRD or it really doesn't work. It really gets unhappy. And you need one if you're going to run any kind of LVM on, if your root file system is going to be on LVM or if you're going to use device labels. And one of the things about the Red Hat one is they always mount /proc because you cannot find a device by its label unless you have /proc partitions. All right, so the various types of mount commands, things like that are using device labels, what they actually do is walk over /proc partitions, find every partition, and issue an I/O control on it to find out what its label is, if it has one. And if you did an strace of that process, strace mount label equals /, then you'd see it walking over /proc partitions and doing an ioctl and having the ioctl fail, inappropriate ioctl for device, on everything that's not a Linux file system with a valid label. All right. So where were we going? We looked at Watchdog.
What's a Jiffy's? I see that in here too. There was I wanted to ask before.
Right, so one of the things that the kernel keeps track of in its timer loop is this concept of a thing called a jiffy. And it simply keeps incrementing the jiffies until they wrap around. Now, this used to be a 32-bit value, so it used to wrap around in 490 some odd days. And it used to be kind of a point of pride for people on the Linux news groups back when Linux was on alt.linux.something or comp.os.linux, for those who ever saw it there. And on some of the mailing lists, people would brag, my Jiffy's wrapped around. In other words, my system was up for an entire year, and then some. Now, Jiffies are actually 64 bits, even on a 32-bit platform. They actually use a pair of registers for them, and on 32-bit systems. So wraparound won't happen in your lifetime. Now, remember we mentioned BOGO MIPS a while back? What the kernel does for BOGO MIPS is it counts how long it takes to do essentially nothing. And the reason it does that is that it used to use that for very small delays, for busy loops in device drivers.
Only eventually it got used more for as far as how brilliant this box is.
Well, and it would report them, but the reason it was figuring out how many million times it could do nothing in a certain, in one timer tick, actually I think it used a number of timer ticks and averaged them. But the point is, the reason it was doing that in the first place was to figure out how many of these it would have to do in order to do nothing for a measurable amount of time that was useful for device drivers, for short waits. And in fact, you can look up udelay in your kernel sources and find, go back up here. I was actually just looking at the udelay function. Now it's defined on every architecture separately. You're going to find a lot of this, by the way, at least for the lower level type functions. Now I remember finding, oddly enough, that there isn't one for 386 here.
Second from the bottom.
Oh, there it is. That's why, because we're looking at a 2.4.24 kernel. So what the new one does is it calls under udelay. That's something else you're going to find a lot. And so I got the right one there. This one calls a kernel or CPU relax. Right here. So notice what it does here, loops per jiffy times hertz times usex. Now if we go back to where this thing is defined, the pound defined for it says, if the number that you've passed to this thing is over 20,000, then this is defined as something like bad delay time. We'll go back and look at it in a second. But basically it's enforcing you can't call me with more than 20,000. I'm not going to do that. That's too big for a udelay. So this one doesn't do that kind of checking here.
Micro is what it said.
Yeah, dude, that's too long. And then the CPU relax, actually, now again, it's defined for every processor architecture, all over again.
Twice for x86.
Once for 32, once for 64, yes. And here, as I recall, hey, wait a second. Oh, it's up there, yes. It's that one right there. Rep no-op, which, by the way, just translates to a small piece of assembly you find over here.
I'm guessing rep for replace.
Yeah, repeat no-op. Rep is a prefix in the x86 instruction set. And I wanted to go back one more and, wait a second, one more. Yeah, here. It translates to bad udelay, which I presume just gives you a kernel message, a print K or something.
So Jim, I heard you were able to improve the efficiency of udelay by a factor of 4.
That would be a futile gesture. So where's bad U delay? There it is. It's up here, and it's just clearing it as external. So we'd have to look it up again. Yep.
What's the difference between delay and end delay?
On delay means go faster? Sorry. Actually, I don't know. I presume that end delay means that you can have larger values that I'm willing to delay for a longer time.
A bad end delay list in there too.
Well, let's look it up. You have any idea how hard it is to type when you're looking over your shoulder?
Well, if your neck can actually do a 180.
Yeah. You know what I should have done? I should have brought that other keyboard this time and plugged it into this thing.
Built-in constant key of
Again, it's external.
This is where it's declared. It's a .8.
Yes.
Yeah, line 25.
Thank you.
That's referenced.
It still says over 20,000 bad end delay.
Well, that's a macro, but the macro references something that's extern void.
Right.
Declared extern void, not defined in this file because it's a .h.
That's because of the underscores, but the non-underscore version, which is defined below, is that one. The difference seems to be that one of them is multiplying by 10C7 UL, and end delay is doing it by 5 UL, which is a much smaller value. Micro, nano. Yes, thank you. So let's look up jiffies. Which is plural. There. Now that's not where I expected to find that.
Try singular, J-I-F-F-Y.
Actually, I'm thinking what I really need to do. You think it's with a Y?
J-I-F-F-Y is the singular.
Well, yes, but I think it's used in the kernel as jiffies, and I think it's another symbol. It's not part of a function name. Jiffies. Kernel time. I was just in here earlier today, so I knew that was going to be there somewhere. Well, it's not a function. It's declared as a variable in one of these functions. Actually, you see that export symbol jiffies?
Could be the right file.
And this, it is. So this whole thing about export symbol, when you use symbols inside of your modules in the kernel, they're local to that module unless you call the export symbol macro to export it to the rest of the kernel where it becomes part of the symbol table. So for example, remember I told you about the ugliest piece of kernel hacking that I've ever done, which I would never submit to the real kernel hackers for, consideration?
Remember, you're on camera.
Oh, well. So in that case, what I was doing is they had consolidated a bunch of stuff in the MII tool, the media independent interface for Ethernet configuration stuff, and also some ETH tool stuff. So they had consolidated a bunch of that into one place, but I was trying to backport a newer driver, which was written with this consolidated, set of essentially libraries in mind. I was porting a couple of Ethernet drivers from that back to a 2.4.21 dash something or another kernel so that it would run on a completely unmodified kernel but be able to use those drivers. So what I ended up doing is redefining some of these local symbols in my modules, even though they didn't exist in that kernel. But I didn't export them, I only kept them internal. So I wouldn't clash with anything else that might have tried to use them. I think in one case, one of the things I was doing was an exported symbol, it was just being used differently in the interim. And in at least one or two of the other cases, they had never been exported symbols before. And so when you compiled these, it now created these new external symbols which would fail to load on the old kernel unless you completely rebuilt the old kernel, which of course I couldn't do. That was the whole point of the exercise. So anyway.
Name collisions, one of the reasons why C++ was invented.
Now, as I recall, what jiffies were originally used for is for various parts of the kernel to check and see if a small amount of time had passed. You were obviously never supposed to use them for a large amount of time, but it was for an internal timekeeping functionality.
Talk about internal timekeeping. We've got a couple more minutes left.
Okay, so I'm going to close with the question I started a little while ago. What are some of the things you would expect a kernel, any kernel, to have to do, and especially the Linux kernel, during its principal timer interrupt?
Scheduling.
So I don't think it would have to check interrupts. It might have to, update the system clock, update the Jiffy's value, schedule processes. In other words, sometimes it's going to be giving time slices to a process. Sometimes it's going to be giving time slices to a kernel thread, which for the most part it treats as processes. It gets to use the same scheduler for both. That was one of the whole reasons why they spawn those out, so that they're even visible. When you do a PS listing, you see all those kernel threads. And I think at least one of those kernel threads actually participates in the deciding where to put things into the run queue. But when there's something at the top of the run queue and when it's, then it's going to actually give that some time. What else is it going to have to do? Somebody mentioned soft IRQs or any of the deferred. In other words, it's going to have to do any of the the top half handling for any of the interrupts that have already occurred. That's scheduling. Decide what to do next is scheduling. It's the heart of scheduling. Right, the kernel is going to do some of its own bookkeeping, and then it's going to schedule either kernel tasks or user space tasks. And kernel tasks will include things like running the bottom half handlers, the K-soft IRQ stuff. Also keep in mind that it's going to be happening on every processor is going to be getting these timer interrupts. So all of them are going to be running this. So let's go ahead and try and find the thing. Now, of course, I cheated. I said do_timer, right? But how would you find out that whether or not that's correct, or how would you have found something like do_timer if you didn't know where you were looking?
Start timer stuff.
Time stuff?
I think that's going to return a lot of hits. Now, you might just look on file names. There is a timer.c. That would be a good guess. There's also a sked.c, and look at the relationship between the two files. Which things in one file are calling or being called by the other one.
That obviously needed timer activity, and then they're looking for it.
So Heather suggests, find something of the things that you figured have to be happening, like updating the jiffies. You could go from there, do a reference search, and find out who's calling the update jiffies function, and look backwards. You could also do some kind of Google search, like maybe Linux, kernel, timer, interrupt handler, which is actually the one that I used. So the reason I mentioned that last one is we don't have to feel like we're stuck only trying to use the kernel source code directly. And we did this at the end of last week too. We said, wait a second, I'm not understanding really what's going on here. It was actually in the discussion of Ksoft IRQ. Right? And so we went and did a Google search on it to go and see if somebody has written a white paper or a how-to or some kind of commentary on it for, those of us who are like trying to figure this stuff out. So I'm reiterating that one once again, yes.
Tracking down one of the things this evening, I ran across the website kernelnewbies.org, which looks very topical to our group. And it has been around for quite some time.
So that would be the .com domain squatter there.
That guy doesn't look like him.
He doesn't look like a kernel hacker either. For one thing, no beard.
And that looks like a plastic.
Which is actually an ironic statement when you consider the fact that Linus Torvald himself has no beard.
But he's wearing a jacket and tie.
I don't think I've ever seen Linus wearing a jacket and tie. I know, I understand.
You're not the kernel hackers you're looking for, move along.
They have a web forum. We can post questions there.
Has Linux ever worn a tux? For Linux.
Well, he got married at one point.
Wait a second. I have never seen him in one, but then again, I don't see him that often. Especially not since he moved up to Portland. I haven't bumped into him in Fry's in years.
Yeah, he's never touched the price Sunnydale anymore.
Well, you don't know that he hasn't, just that he hasn't during whatever you're doing.
That's true. Yeah, he might. He probably goes to Fry's Wilsonville.
So, Jim, do you want to do this next week, or do you want to do the one on
So, right, on the matter of closing this session up, one of the things that I have said is that we will rapidly run out of, run to the point where I won't have 2 hours worth of stuff to say about the kernel because I just don't have time to do that much reading between one shift and another. Like a lot of this reading I was doing at about 4:30 this afternoon during the other class that I'm taking actually for work. I'm sure the instructor was thrilled. So, Paul, you said you had somebody else who was lined up who had some material that he would like to cover next week?
We have a couple different people that have tugged on my shoulders about, on my shirt about, hey, I'd be interested in talking. And so what I was thinking to do was to have you kind of be like either every other meeting.
Right. I'll try and show up as the appointed heckler. Oh, that was my outside voice again. Oh.
If somebody has like 2 or 3 sessions worth of something that they want to break up across multiple sessions,
Yes.
you let them run that whole run and then have you come back to look at other issues or.
Yes. Now, what I will recommend, so you're going to select somebody and post that perhaps to the wiki, to the website, or we'll just do it as a surprise when we get here. Meanwhile, I'm actually going to highly recommend that people get out there and actually read parts of this, and especially, as I said, ask yourself what parts you're interested in. Try and envision what you think probably should be there, what kinds of functionality, what kinds of functions you might expect. Then go look for it. Look at a character device driver. Look for other things that fill in these FOPs, things like that.
Question of timing.
What's that?
Are we gonna do this on the Tuesday
guys wanna keep rolling with the thing, and Google's willing to open the doors and all that, and you wanna keep going without me over at Christmas holidays, more power to you.
Why don't we take a quick poll for planning purposes? How many people here are going to, are thinking that they would want to show up here in this room on Christmas, whatever? I,
I would show up, but I think that we should defer it just because I think that there will be a lot of people doing stuff, not to mention, if we want the AV people to come, I'm not sure if they're gonna be there.
right, okay, so I am seeing only 2 votes for the idea, plus a vote against it that kind of trumps us all, because he actually works here and would be the person opening the door for us, not to mention the AV people,
He would, but
so.
he doesn't think the AV people would.
I would come, but I don't think the AV people would.
Right.
So I don't think it would be.
I'm kind of thinking we should decide right here and now that we are not going to show up here during the week of Christmas.
There you go.
Yay. Executive decision, even though I'm not an executive.
Who says? All right.
Okay. So we will have a different speaker next week. Darlene?
Find out what they're gonna cover, so if people wanna prepare and read it, you know.
As soon as
Yes.
someone volunteers and says what
Yes.
That's Tuesday the 25th. That's Christmas Day. No one's gonna be here.
Right, I hope not. So,
if Christmas Day is a Tuesday, then so is New Year's.
okay. So Christmas Day and New Year's Day, we will not be here. There.
I will attempt to have whoever's gonna be speaking next week communicate with the entire SVLUG list about next week's topic as early as they can.
Okay.
Tell everybody.
I would like to continue to suggest that we make the wiki kind of our central point for doing this. One of the reasons for that is that some of us don't want to subscribe to the mailing list and don't want to subscribe to yet another mailing list and would rather be in kind of a polling, fetching mode rather than a, pull it in rather than a get it flooded with it.
Not to talk
But
about
if you need to log into the
but I
wiki,
think that we should have a calendar that has these on it, because then everyone can be.
The Google Calendar.
So Warren is also suggesting that we set up a Google Calendar to actually track the dates. And we can make a Google Calendar public and make links to, for instance, the wiki there.
Yeah.
If we make a Google Calendar, might as well put all SVLUG events in it.
Oh my God.
Perhaps, if you like. Okay.
You're welcome to take it there if you want to.
run the
I do have
No, I am not.
I do have a question.
What's
Could
that?
someone, whoever updates the front page, we can get them to put this event.
Yeah, I saw that
Yeah,
today.
I
I was
can
like, I don't know why this event's
I can-
not
I
already
can
on
do
there,
that.
but you wanna handle that?
Yeah.
Awesome.
All right. So we're going to update the actual SVLUG webpage.
If you help me tweet the subpage to which it's supposed to point.
One other matter, when you're updating the wiki page, I would suggest that actual content go on the resource page, on the main one, and discussions about, who's sponsoring it, where we're meeting, all that stuff should go on the discussion page, not on the main page. Because my view of what the resource should look like on the wiki is anybody coming along should be able to start reading that and going, okay, if I was just going to kind of follow along at home or do this all over again and try and catch up to them, what would I do? And that's what I want that page to be, is a set of resources that say, well, we go here, and then we look at this, and this is what we do here. And if they're curious about some of the dynamics that are related to the mechanism or the meta information, they'll hit the discussion page if they're at all used to any of the Wikipedia type stuff.
Sure.
And thank you all once again.